A new survey of nearly 2 million galaxies reveals that dark matter could be even more abundant than previously thought. Dark matter is one of the biggest mysteries in astronomy today, but scientists have a pretty good idea that it makes up a quarter of the entire universe. It's just invisible. We can only observe its effects on the things around it. One such effect is its gravitational pull on galaxies. And by studying how galaxies move, astronomers are able to learn more about this elusive substance. In a recent study, they analyzed nearly 2 million galaxies and found that dark matter may be more widespread than we thought, making up as much as 80% of the mass in some places. Before we get into the details, let's first explain what dark matter is and why it needs explaining in the first place. The reason we think there is such a thing as dark matter is that we can observe the effects of gravity throughout the universe, and we can see that those effects don't always match up with what we'd expect if only regular matter were present. For example, stars in galaxies rotate faster than they should, and galaxies rotate faster as a whole than they should. All the way across the cosmos, galactic clusters move in ways that suggest there's far more mass present than we can actually see. Now we know that space is made up of more than just regular or baryonic matter. Stars, planets, and people are all made of this stuff. But so is light and other forms of electromagnetic radiation, as well as the hypothetical dark matter. All of these things have mass and therefore exert a gravitational pull. But when astronomers look out into the universe, the only stuff they can actually detect is the light and other forms of radiation. So it's important to distinguish between the two. Visible matter is what we can see because it emits or reflects light. Dark matter, on the other hand, doesn't interact with light at all, which is why it's called dark. Since we can't see it directly, we can only infer its presence by observing its gravitational effects. This is similar to how you can tell that there is air around you, even though you can't see it. You don't see the individual molecules, but you do see their collective effect on the things around them, like the ripples in the pond when you throw a rock into it. But just like we know that air is mostly made up of nitrogen and oxygen, we have some clues as to what dark matter is. Physicists have developed several models for what dark matter might be, and they're looking for particles that could make up this mysterious substance. Experiments at particle colliders, like the Large Hadron Collider, have unfound any evidence of these hypothetical particles yet, but that doesn't mean they don't exist. It just means that they might be more elusive than we thought. One possibility is that dark matter particles are so weakly interacting that they almost never produced in particle collisions. The problem is, without direct evidence, it's hard to know how to look for them. Luckily, astronomers have found another way to test our theories of dark matter by studying its gravitational effects on galaxies. To measure these effects, astronomers need to know how fast stars are moving around the center of galaxies and how far away from the galactic center they are. With that information, they can calculate the amount of mass needed to produce the gravitational pull that keeps the stars in their path. If they find that there's more gravity than expected, then there must be more mass than they can see. And since they can't see it, they attribute it to dark matter. This is the same basic method used in the recent study published in the journal Astronomy and Astrophysics. But instead of looking at just a few galaxies in detail, this team studied almost 2 million of them. They did this by analyzing data collected by the Hubble Space Telescope as part of the Cosmic Flows to Survey. The team wanted to understand how the distribution of dark matter relates to the distribution of normal matter in the universe. To do this, they needed to map out the distribution of galaxies in 3 dimensions. That meant they had to take into account not just the positions of the galaxies, but also their distances from us and their velocities. Once they had that map, they could use computer simulations to model how the large-scale structure of the universe affects the motion of galaxies within it. The simulations took into account the effects of gravity on both normal and dark matter. And by comparing the results with what astronomers actually observed, they were able to estimate the amount of dark matter in each galaxy. On average, they found that dark matter makes up about 60% of the mass in galaxies like the Milky Way. But the amount of dark matter varies depending on where you are in the universe. In the places with the most dark matter, it makes up as much as 80% of the mass. What's more, they found that the amount of dark matter in a galaxy is related to how far out its stars are from the center. Galaxies with a larger distribution of stars have more dark matter. This makes sense because the further a star is from the center of a galaxy, the more massive the region it must be bound to in order for gravity to hold it in place. And that means there must be more dark matter there too. The results of this study are consistent with those of previous studies. But by looking at almost 2 million galaxies, the team was able to produce the most detailed map of dark matter ever. The next step will be to compare this map with the distribution of dark energy. That's the mysterious force that's speeding up the expansion of the universe. By understanding the relationship between dark energy and dark matter, astronomers hope to learn more about the fundamental nature of both. After all, together they make up 95% of the universe, but we still know very little about either one. In some ways, studying dark matter and dark energy is like trying to understand the weather. Just like meteorologists need detailed information about the atmosphere in order to predict tomorrow's weather, astronomers need detailed information about dark matter and dark energy in order to understand how the universe evolved from the Big Bang to the present day. But while weather forecasts can be wrong, astronomers are increasingly confident that dark matter exists. The more data they collect, the more the predictions of the standard model of cosmology agree with what they actually observe. And that means that our understanding of the universe is becoming more complete with every new discovery. Maybe someday soon we'll know exactly what dark matter is. But until then, we LL just have to marvel at the fact that there's so much more to the universe than meets the eye. So, what do you think? Is there anything we missed? Let us know in the comments below. And don't forget to subscribe for more videos like this one. If you enjoyed this video, you might also like our video on time crystals, which are one of the strangest phenomena in physics. Time crystals are a relatively new area of research, but they've already generated a lot of excitement among physicists because they seem to break the laws of thermodynamics. At first glance, time crystals look like ordinary crystals, but they're actually very different. Crystals are solids whose atoms are arranged in a regular repeating pattern, but time crystals are made of atoms that oscillate back and forth in a repeating pattern. This means that time crystals have a period of oscillation, just like a pendulum clock, and that period is always the same, no matter how small the crystal is or how quickly it's moving. Physicists are still trying to understand how time crystals work, but they're already developing ways to use them to perform computations and store information. In fact, some researchers believe that time crystals could be the key to building a fault-tolerant quantum computer. But whether or not time crystals turn out to be useful for this purpose, they're fascinating in their own right. They're one of the most bizarre phenomena in physics, and they're sure to generate a lot of excitement in the years to come. Thanks for watching. See you next time.